morning, fees. Great question. So I'm going to work this, how you get the inverse of this. So let's see here. Switch X and Y just is a nice visual way of knowing what you're doing. And then multiply that to the other side. Get everything to one side, because what I'm going to do here is, since this is a quadratic equation with the highest power 2, I'll use the quadratic formula. So then you'll have y squared plus 5y minus xy minus 4x plus 5 equals 0. Where I kind of moved all that to the left side, but then also wrote it where this is on the left side equals sign. Now recognize that if I factored out the 5 and minus x here, those are just numbers, right? And those are just constants. So this whole thing is just some constant. And then this right here, I'm actually going to do plus negative 4x plus 5 is some constant too. So then we can do the quadratic formula to figure out what are the y values that set this equal to 0, but also actually gives us the equation. So then you get y equals negative b plus or minus b squared minus 4 times a, which is 1, times c, all over 2 times a, which is just 2 here. And then what you end up getting from here, and there's some interesting things that happen. So remember that this function right here, y is the inverse, right? Y is the inverse. I guess that's why I don't like calling it y. So we're talking about the inverse of this function up here. And remember, the goal, I didn't really say that in the beginning, is to find the domain of the inverse, as that will represent the range of the original function. And then you have 5. That would give you 5 multiplied out 25 minus 10x plus x squared. That would be plus 16x minus 20 all over 2. And then we simplify it one step farther. You'd be at negative 5, so x minus 5 plus or minus. And in here, we'd have x squared plus 6x plus 5 all over 2. Now, remember, the goal is we're trying to find the domain of the inverse. Well, if we're just looking at the x minus 5 over 2, if that was the function, the domain would be all real numbers. The problem here is that square root, because we can't square root a negative number, because we're working in the real number system, complex number system. Everything gets thrown out the window. So we just basically want to know for the domain, when is the square root of x squared plus 6x plus 5, when is that greater than or equal to 0? As that will tell us our domain. Well, we can actually break this up as x plus 5, x plus 1. When is that greater than or equal to 0? Which is nice for us. All right. Now, what's interesting about this is you have, something times something. Well, the only way these are greater than 0, and I'm going to make a number line. Help you see this. Well, we know that at negative 5, there'd be a 0. That would be a 0. And we know at negative 1, that would be a 0. What we're going to do is we're going to check the intervals on the outside, the middle, and the inside and see, are there possible x values that we can still have that we can plug into this equation, so it'd be part of the domain. Well, if you had a number less than negative 5, say negative 10, that would make that a negative, and that would make that a negative, and a negative times a negative is a positive, so that's possible. So any number on the left of negative 5 will create a positive, which again just means that it's possible. But if you look at a number between negative 5 and negative 1, say negative 3, well, that would be a positive, and that would be a negative, and a positive and a negative would make a negative, which means that it's not possible. And then outside of negative 1, say we looked at 0, or any positive number, 100, those would both be positive, so then a positive times a positive is a positive, so that's possible. So from this right here is technically the inverse function. And maybe you could simplify it more, but I mean, that is an inverse function, just kind of messy looking. And what's the domain of that? Well, the domain of that, the domain of the inverse, which let's start using -1, so you can see that that's the inverse, is -infinity to -5, with the union of -1 to infinity. In which case, you saw in the problem that we did, Hafiz, and this is really awesome because I was quite amazed myself when it worked out, that this ends up becoming the range. And if you looked at your graph of the original function y, in which case -5 and -1 was that maximum and minimum on each side of that asymptote. So that's how it works for this problem. If you wanted to generalize it, I was trying to do it a little bit this morning, but it gets a little bit messy, but it's basically generalizing, because this is what you do if you ever major in math, is you try to find something that works for all situations. So if you looked at a function, some rational function of this order, ax squared plus bx plus c all over dx plus e, such that, or where a, b, c, d, e are elements of the integers, meaning they can be any number. If you tried to prove all this again, is there a nicer way of just saying, hey, if you just take a, b, c, and e, do this algorithm to them, and what happens? Maybe you'll get an answer. And that would be where you go. I know that you can tinker around it. Maybe there's a different approach. It gets kind of messy, but that's the general form, which I don't even know if that's possible, but that would be the next step here. But really cool up here, how it worked out. Hope that makes sense to you. If not, just ask.